Hey, when we look out at the stars, we assume we're living in a giant, endless room. But for decades, cosmologists have been trying to figure out the actual geometry of the container we live in. Is the universe a flat sheet, a curved ball, or a giant cosmic donut? The answer depends on a high-stakes tug-of-war between gravity and expansion. This is the mystery of the shape of the universe. The three possible shapes. In Einstein's general relativity, the shape of spacetime is determined by its density. There are three main candidates. Flat, Euclidean. If the density of the universe is exactly critical, space stays flat. Imagine two laser beams fired parallel into space. In a flat universe, they will stay parallel forever. Closed, spherical. If there is too much matter and energy, gravity curves space back on itself. In this universe, if you travel in one direction long enough, you'd eventually end up right back where you started. Those parallel laser beams would eventually cross. Open, hyperbolic. If there isn't enough matter, space curves outward like a saddle. In this version, the laser beams would diverge and fly away from each other forever. The triangle test. How do we test this? We look at the oldest light in the universe, the cosmic microwave background, CMB. Astronomers use the spots of heat in this afterglow to draw a massive triangle across the cosmos. On a flat surface, the angles of a triangle always add up to 180 degrees. On a sphere, they add up to more. On a saddle, they add up to less. When the Planck satellite measured these points with incredible precision, the result was almost perfect. The universe appears to be flat, with only a 0.4% margin of error. The flatness problem. This result is actually a huge headache for scientists. For the universe to be this flat, the density at the moment of the Big Bang had to be tuned to an impossibly precise level. If it had been off by even a fraction of a fraction, the universe would have either collapsed inward or flown apart before the first star could even form. This led to the theory of cosmic inflation, suggesting the universe expanded so fast in its first second that it stretched any curves flat, like a balloon being blown up to the size of a galaxy. The donut loophole. Just because space is flat doesn't mean it's infinite. Think of a video game like Asteroids or Pac-Man. If you fly off the right side of the screen, you reappear on the left. The screen is flat, but the topology is connected. Some physicists believe our universe might be a 3 torus, essentially a 3D version of a donut. It would look and feel flat to our telescopes, but it would be finite, meaning the universe has a specific volume and doesn't go on forever. Whether we are on an infinite sheet or a giant cosmic loop, the shape of the universe is the map that tells us where we came from and where we're going. Pretty wild, right?